Today we're going to talk about polynomial synthetic division. Now understand, this is just another way of dividing with polynomials, meaning we've already done polynomial long division, we've already had the video on that. You don't get different answers by doing division with synthetic instead of long division. They still both give you the same answers, they are simply two different methods to find the same thing. Synthetic division is intended to be somewhat of a shortcut. It's meant to speed up your process of dividing. Now, with most things in math, as you guys have probably learned by now, when we talk about a shortcut in math, usually that does mean you can solve the problem out quicker, and you can generally have to write less things. But the flip side, the bad side of that, is that a lot of times shortcuts tend to mean that you have some extra rules you have to remember, or there's a little bit of extra stuff you have to be doing in your head. And this is no different. As you can see, we've got some different rules here. So these are separate rules you would need to learn alongside long division if you wanted to know how to do both of these, which in this case we do. For synthetic division, from the first step you can already see why it's considered a shortcut, or why you could consider it a shortcut. You are only going to list the coefficients. Remember, coefficients are the numbers in front of variables, meaning unlike long division, you don't have to write out the x's along with the numbers to do this division. But you can also see there's some extra setting up that we have to do for that to work out based off these other steps. For example, whereas in long division, whatever the second polynomial, the second expression was, you would just put it outside the box. This time you're going to have to set it equal to 0 and solve before you put something outside the box, which I'll show you what that means. The rest of it does kind of have some relation to what you guys already did, so the rest of it may feel a little bit similar. For example, to walk through one of these to show you what we're actually talking about here, let's say I asked you to take the polynomial x to the third plus 5x squared plus 6x plus 9, and I wanted you to take that polynomial and divide it by x plus 3. Okay, that's the example we're going to do here. So if we did that, first off, your box is going to be kind of upside down from what it was when you did long division. Now it's actually going to look somewhat like a really badly written L, as opposed to, I don't know, whatever you wanted to say the long division box that you would draw is. So inside the box, we are still going to be putting our first polynomial. Just like with long division, the first polynomial we are given, the expression that is being divided by something, that is what we're going to put inside the box. Like the directions say, though, we are only going to use the coefficients, meaning for x to the third, we'd ask ourselves, what is the number in front of x to the third? Well, we know if it doesn't show us, then there's really a 1 there, so we'd put a 1. Notice I am leaving space for a second row in this box. You want to leave space for 2 rows of numbers in this box, by the way. After the 1, I'd move on to the next term, x squared. So I'd say, okay, what's the coefficient? What is the number in front of x squared? And we can clearly see that is a 5. And I'd say, okay, next up is x to the first, right? We went x to the third, x to the second, x to the first would be next. Its coefficient we can see is a 6. And then finally, we deal with the constant, or effectively no x's, x to the 0 power. And that constant is 9. Those are our numbers that we write inside the box. Again, notice while the rules are taking a little bit for us to talk through, the actual writing is saving us time because I didn't have to write the x's. Outside the box, we also don't want to write x's outside the box. So in long division, we would have just wrote the entire thing of x plus 3. Or I would have wrote this whole second expression outside the box. We aren't going to do that here. Instead, what we're going to do is we are going to take this x plus 3, I won't write it over there, write it here, and we are going to set it equal to 0. And then we want to solve that out. Well, if you take x plus 3 equals 0 and you want to solve for x, how would you do that? The opposite of addition is subtraction, so we would want to subtract 3 to the other side. That gives us x equals negative 3. Whatever x equals, that's the number we use for our side number on outside the box. So we have that -3. Okay, meaning you can ignore all of this stuff now. You can basically get rid of it if we really wanted to. Okay, that's what we're looking at here. We took x plus 3, we set it equal to 0, solved it out. That's where we got that side number. That is all your setup. So, while it is a shortcut, you have to know all the rules to set it up correctly for it to be a shortcut. Right? Because the rest of what we're going to do, as you're going to see, it's really not that hard what we're going to do. But you had to get it set up correctly for that to help you. Okay, so that was all rules for how to set up your synthetic division. Now, to actually do our synthetic division, here's how it works. First step, every time, no matter what, take your first number inside the box, drop it all the way down outside the box. You're going to be writing your answer as what we're going to get on the bottom row here, okay, outside the box. So whatever that number is, whether it's a 1 or something else, drops all the way down. The rest of this is going to be alternating between multiplication and addition. If you remember with long division, every time we wrote part of our answer, we'd have to multiply that answer back to the side so we could subtract it away. Just like that, in synthetic as well, when we write an answer outside the box, we have to multiply it back to the side. Well, we just wrote an answer outside the box. We wrote that 1. So now we have to take 1 and multiply it back to the side. If we take 1 times -3, we would get -3. So we will write that underneath the 5. That was multiplication. Now we do addition, meaning we're going to take 5 plus -3. We're going to add down through this column right here. Well, 5 plus -3 is 2, positive 2. 5 minus 3 effectively. Now that we've written another number outside the box, we will have to multiply that back to the side. So we would take 2 times -3, the multiplication part. 2 times -3 is -6, so we write that here, and we rotate back to addition. It's multiply to the side, add, multiply, add, multiply, add, back and forth till we're done. 6 plus -6, adding down through this column, 6 plus -6, or 6 minus 6, is 0. That's another part of our answer, so now we have to take 0 and multiply it back to -3. 0 times -3 is 0. Now that we've done that multiplication, we need to add again, so we would take 9 plus 0 to get 9. Alright, it's kind of a weird process, but it is pretty straightforward. It's just switching back between multiplication and addition. There really isn't anything else to it. That's the good news. Now that we've got done with it, we are ready to get our answer. Now obviously what you have sitting in front of you is not exactly what our answer should be here, because a random string of numbers of 1, 2, 0, and 9 is not really going to work as an answer. So here's how this is going to work. Okay? Look at what you started with. You started with an x to the third, and then you divided that by an x. Well, if you were taking an x to the third and taking an x away from it, then you would have an x squared left. Or, to say it even easier, when you want to write your answer, you're always going to start 1 degree, 1 exponent lower than what you originally started with. Meaning this one right here, this one right here represented the x to the third coefficient. When we do our division, our final answer is going to start with an x squared. So we have 1 x squared, which would then make this a 2x to the first, which would then make 0 a constant, right? So no x's with it. And then the question is, what does that 9 represent then? Because I have no more variables for 9 to represent. Well, the last number that you get from synthetic division will always represent your remainder. The last number from a synthetic division problem will always represent your remainder. If you will recall from long division, What we want to do with remainders is we want to write them as fractions, right? So when we talk about remainders, we are literally saying this is what we have remaining that we were not able to divide. If we weren't able to do the division, then we will simply write it as a division problem, which we know fraction bars represent division. So along with the 1x squared plus 2x plus 0, we will also have 9 written as a fraction, and the question is simply what the bottom of that fraction, the denominator of that fraction, needs to be. Well, let's look back at our original problem and ask ourselves, what are we dividing by? We were dividing by x plus 3. So, we will write that we were supposed to take 9 divided by x plus 3. Right, we are literally saying we weren't able to do this division, but we're still going to write that there was division left to be done. If you don't like having the 0 there, you could also rewrite that, or just to simplify it, make it look nicer, as x squared plus 2x plus the fraction of 9 over x plus 3. That would be the simplest form that you could write this answer as. Let's take a look at another synthetic division problem to show you the couple of wrinkles that you could have with doing this method. So if we're taking x squared minus 4 divided by x plus 2, if we want to set up our synthetic division problem, the important thing to recognize is that when I go to put my coefficients, certainly I'm going to start with 1 because that's the coefficient of the x squared term, right? That's a 1 in front of there. But we don't get to immediately go to negative 4 as our other number to write inside the box. If you have any missing terms, you have to put 0 placeholders in for those, meaning notice that we go from x squared straight to just a constant, just the negative 4. Well, what happened then is we skipped an x to the first term, right? Usually it'd be something x squared, something x, then our constant. So what we have to do is, instead of looking at this as x squared minus 4, really what you want to think of this as you want it to be looked as x squared plus 0x minus 4. Alright, now you don't have to rewrite it that way if you can think about it in your head, but you have to check for any terms that are skipped, any missing terms. And if there are, you need to put a 0 placeholder in there. Then you can continue on. So that's how this should be set up. We have our x squared term, we have a 0 for the missing x term, then we have our negative 4 for our constant. The rest of this we're going to finish out about the same way. Take your second expression, the x plus 2, and you want to set that equal to 0 and solve out. In this case, to solve out, all you would have to do is subtract 2 to the other side, giving you x equals negative 2. So that will be our side number. We always take the first term and drop it all the way down outside the box. And then remember, we multiply back to the side, and it's just alternating between multiplication and addition for the rest of this problem. So 1 times negative 2 is negative 2. 0 plus negative 2, or 0 minus 2, is negative 2. Negative 2 times negative 2 would be a positive 4. Negative 4 plus 4 would be 0. And that is interesting because if we have a remainder of 0, that just means that we're going to be able to solve this out perfectly. So to finish out this problem, we started with an x squared function, so that means we drop down to this just being an x to the first, which would make this minus 2 a constant, and our answer really is just simply x minus 2, or 1x minus 2. No fraction, nothing like that, because we don't have a remainder.